Warning: serious injury or death may result from the use of the equipment and techniques described in this tape. It is not intended to be used as a sole source or replace field training by competent instructors, nor is it a substitute for experience. The equipment and techniques shown may or may not be appropriate for a given rescue situation. It is the strict responsibility of the user to obtain thorough and qualified instruction in any and all rescue equipment and techniques. This tape is provided with no liability to the authors, publishers, or distributors, expressed or implied, in the case of injury or death to the purchaser or viewer. Welcome to High Rope Tech, the video series. I'm Dr. Bill Ramsey, along with Kyle Eisenhart. All the volumes of High Rope Tech are designed as an aid to learning the fundamental principles and techniques of rope rescue. There are many areas other than fire departments and rescue squads where rope rescue competency is important.
That's right. Police tactical teams, municipal high-angle rescue teams, industrial confined space organizations, the military, all these groups, although they sound quite different, need to know the same fundamental principles of high-angle rescue.
And principles are important. All those teams may have their own preferences for equipment and techniques, but all those preferences must be based on sound principles. Throughout the High Rope Tech series, we hope to bring you those basic principles. This is Volume 2, Knots and Hitches. We will discuss only those knots necessary for a safe and effective rescue. The goal of a good rescuer should be to utilize the fewest number of knots necessary for a safe and effective rescue. The following knots and their applications will be discussed: the figure 8 family of knots, the bowline knot, the butterfly knot, the double fisherman's bend, the overhand bend, the prusik knot, and the clove hitch.
Before discussing each of these knots, the terms knot, hitch, and bend should be clarified. A bend fastens two rope ends. A hitch connects a rope directly to another object. A knot is any tying in ropes other than hitches and bends. But in its broadest usage today, the term knot is commonly used to cover all types of ties in ropes. There are really only three basic functions which knots must serve in rescue situations: to put a loop in the end of a rope, to put a loop in the middle of a rope, or to fasten two ropes together. The figure 8 family of knots perform all three of these functions and will be discussed first.
The figure 8 on a bite is the first of the figure 8 family we will discuss. This variation of the figure 8 knot is used to place a non-slipping loop in the end of a rope. This loop can then be attached by a carabiner to bridles or harnesses. The figure 8 on a bite is also used to place a non-slipping loop in the middle of a rope without access to either end. To tie the figure 8 on a bite, a loop or bite is placed in the rope. The end formed by the bite is then wrapped around itself, but instead of making only one turn before passing through the loop formed, as would occur with a simple overhand knot, an additional 1/2 wrap is made around the standing portion of the rope and then passed back through the loop. It now becomes obvious why the knot is called the figure 8 knot. Although in the mountain climbing literature an overhand backup knot is not required, a backup knot is used in rescue situations for added safety. The figure 8 on a bight forms a non-slip loop in the middle or end of a rope, and access to ends of the rope is not necessary. Another member of the figure 8 family is the retraced figure 8. This knot, when completed, is identical to the figure 8 on a bight, but must be tied differently because it is used to tie a non-slip loop through a solid ring like those found on a litter bridle or the back of a full-bodied harness. In order to tie the figure 8 retraced, one end of the rope must be available or free. This free end of the rope is called the running end of the rope. The non-free end of the rope is called the standing end of the rope. First, a single figure 8 knot is tied in the rope, leaving at least 1 or 2 feet of running rope. The running end of the rope is then passed through the ring or object to be tied. And then the end is traced exactly back through the single figure 8 knot. Care must be taken to follow each bend in the knot. When completed, the end should exit the knot at the same location that the standing end enters the knot. If this end does not exit at that location, the knot is not tied properly. In rescue, the knot is completed with an overhand backup knot. Once again, this knot is used to tie a non-slip loop into a solid ring or attachment. Using this knot on a litter bridle or on the solid rings on the back of full-body harnesses eliminates the need for a carabiner and provides for one less link in the system. The final figure 8 knot to be demonstrated is actually a bend. The figure 8 bend is used to tie 2 rope ends together. This knot is particularly useful to make a loop of rope for anchoring purposes. To tie the figure 8 bend, 2 rope ends are placed facing each other. As in the retraced 8 knot, a single 8 knot is tied in one of the ropes about 1 foot from the end. The end of the second rope is then retraced back through the knot. It enters at the point where the running or free end of rope number 1 exits the knot. All the same bends in the first rope should be followed exactly. The single knot should be exactly retraced. The second rope should exit where the standing end of the first rope enters the knot. The 2 ends should also be on opposite sides of the knot. If they are not, then the knot is incorrect and may be unsafe. The knot should be finished with 2 overhand backup knots. This knot is used to tie 2 rope ends together, especially for forming a rope loop or sling for anchoring purposes. This knot although not as strong as a double fisherman's, is superior to the sheet bend, the figure 8 bend. To summarize, the figure 8 family of knots will perform all the tasks required of a knot for rope rescue. It will tie a non-slip loop in the end of a rope. It will tie a non-slip loop in the middle of a rope. And it will tie 2 ropes together. There are other knots that perform these functions other than figure 8 knots. Another knot used to tie a non-slip loop in the end of a rope is the bowline knot. The bowline's non-slip loop is particularly well known for its use in tying into the head of a basket litter, and the offline bowline as a non-slip loop to finish off a tensionless friction tie-off for rigging. To tie the bowline knot, first, place an overhand loop in the rope. Then, the free or running end of the rope is brought up through the loop. After coming up through the loop, the running end is brought around the standing end of the rope and back down through the loop. Note that the end of the rope must be brought around the standing end and down into the inside of the main loop, not to the outside. This is not a true bowline and is not as secure a knot. Once the tail is brought down inside the loop, the knot is dressed, and then, to make the knot complete, an overhand backup knot is tied on the loop on the same side as the rope originally entered the knot. The bowline knot, used to tie a non-slip loop in a tensionless tie-off for anchoring purposes and in the head of a wire basket stretcher. The bowline knot. An alternative knot to tie a loop in the center of a rope is the butterfly knot. This knot is especially useful for loops to hold pulleys in the center of a stretched rope. To tie the butterfly knot, a loop or bight is pulled into the rope. This bight is then twisted, and the twist is held open. This twist is held open so that the end of the loop can be brought around behind the entire rope, and then brought down through the twist that was held open. The knot is then dressed. Notice, this knot is tied without access to either end of the rope. The butterfly knot, an alternative to the figure 8 for tying a non-slip loop in the center of a rope. One of the best knots to tie 2 ropes together is the double fisherman's knot, especially where the 2 ropes are in a main haul line. To tie the double fisherman's knot, the 2 rope ends are placed facing each other. Rope number 1, in this case the orange rope, is wrapped around rope number 2 and crossed over the 2 ropes and wrapped twice. The free running end of rope number 1 is then brought up through all the wraps. Then, when the knot is dressed, it is snug to rope number 2. The same procedure is then followed with the free end of rope number 2. Again, wrap twice around both ropes, then brought back through the wrap. It is then dressed to rope number 1 snugly. The 2 knots are then dressed and snugged together and are interlocking. On the back side, all the wraps are oriented in the same direction. The knot is finished with overhand backup knots in both sides. The double fisherman's bend. When one rope is not long enough to reach the full length needed for a main haul rope, the double fisherman's knot is an excellent knot for tying these 2 ropes together and is stronger than the figure 8 or sheet bend. Another bend is the overhand bend, also called the water knot. This knot is used frequently in flat webbing to tie 2 rope ends together, but should not be used in rope because of its weakness. In webbing, the overhand bend or water knot is tied like the figure 8 bend, except the knot that is retraced is an overhand knot. The overhand knot is tied in one end of a piece of webbing. The knot is tied flat and neat. The other end, or piece of webbing, is then passed back through the knot, entering at the point where the running end exits the knot. It is then traced exactly through each bend of the knot. It exits where the standing end enters the knot. The 2 ends should exit at different sides of the knot, or the knot is incorrect. The knot is completed with 2 overhand backup knots. The water knot, or the overhand bend, is used to tie 2 ends of flat webbing together. This can be particularly useful when webbing is tied for a seat harness. A special knot sometimes used in rescue is the prusik knot. This knot is used primarily to aid a rescuer in climbing a standing rope. This is called ascending and was used extensively before the advent of mechanical ascenders. To tie a prusik knot, a smaller section of rope, approximately 1/2 to 2/3 the diameter of the main rope to be gripped, is tied into a loop using a double fisherman's knot. This loop is then wrapped through itself and around the main rope. Then it is wrapped through itself a second time. The knot is then dressed neatly into position. The double prusik knot. Occasionally, more resistance to slippage may mandate that a triple prusik knot be tied. The triple prusik knot is tied exactly like the double prusik knot, except an extra wrap is made through itself and around the main rope. After wrapping twice, like a double prusik knot, A third wrap is made around the main rope. The knot is dressed. All prusik knots have the advantage of holding in both directions. When a load is applied to the open loop, it grips the main rope. But if the knot itself is gripped, it can be easily slid up and down the rope. The prusik knot, used primarily in rescue to climb a standing rope. The last hitch to be discussed is the clove hitch. This hitch is used to attach a rope to another object, especially ladders in rescue situations. To tie the clove hitch, the running end of the rope is first passed over and around the object. Then the end is brought back over itself and around the object again. The running end is then brought back through where the rope entered to begin with and dressed into position. It is usually finished with an overhand backup knot. The clove hitch can be tied and then slipped over an object like a ladder as well. A variation of the clove hitch is called the split clove hitch. This is used to tie a ladder to another object or to tie two ladders together. The split clove is tied exactly like the regular clove hitch, except that the rung of the ladder splits the knot in half. The knot is tied around the beam of a ladder in the same fashion as the plain clove hitch. It goes over the beam and around and then back over itself, but then splits the rung of the ladder, comes back around the beam, and then goes back through where the rope originally entered the knot. It is dressed in position. This keeps the clove hitch from sliding up and down the beam of the ladder. It is then completed with an overhand backup knot. Again, the split clove hitch is used primarily to hold ladders in position in rescue. No discussion of knots is complete without explaining the term knot efficiency. Knot efficiency is defined as the percentage of the original rope tensile strength that is maintained by a knot. Frequently, this value is seen in charts listing the knot efficiency as a percentage of the rope tensile strength, for example, 75%. In order to tie a knot or hitch, the rope must be bent. This bending weakens the rope by a certain amount. The sharper the rope is bent within a knot, the less efficient that knot becomes. Note that the overhand bend has an efficiency of approximately 70 to 75%. This means that only this percentage of the original tensile strength is maintained when this knot is tied in the rope. Notice that the efficiency of the figure 8 knot is greater than the overhand bend because the rope makes more gradual bends than in the overhand knot. The triple fisherman knot is nearly as strong as the rope itself, or approximately 90 to 95% efficient. This occurs because constricting turns add friction to the knot before the rope makes a bend. The values presented here are for 1/2 inch rope. Remember that knot efficiency changes with different diameter ropes. It must be emphasized that although these numbers are useful for comparison, all of the weakening of a rope by knots, regardless of which knot or how many knots, is already accounted for by the safe working load of the rope, as discussed in Volume 1 of High Rope Tech.
Let us now briefly review the knots presented in this volume and their applications. First, for tying a loop in the end of a rope, we have shown the figure 8 on a bight, the retraced figure 8, and the bowline knot. For tying a loop in the middle of a rope, we have shown the figure 8 on a bight and the butterfly knot. For tying two ropes together, we have shown the figure 8 bend, the double fisherman's bend, and the overhand bend. In addition to these three tasks, we have also shown how to attach a rope to an object using either the regular clove hitch or the split clove hitch. Another special knot was included, the prusik knot.
It should be understood that there are several different techniques for tying these same knots. We have attempted to show what we feel are the simplest methods and the easiest to learn. The skill necessary to tie these knots effectively can only be retained by continuous practice. The knots learned here are an essential foundation for rigging principles covered throughout the High Rope Tech series.